Good evening and welcome to day 2 of the Tamil Heritage Trust Indology Festival 2020. Thank you very much for joining us today, and we hope you'll stay with us for the rest of the week as well. Today we have 2 talks by experts on India's prehistory and India's early history, the Harappan period. But before we get there, a quick word about Tamil Heritage Trust for those of you who are new to THT. Tamil Heritage Trust is a not-for-profit trust based in Chennai. It was established in 2010 by a group of friends from diverse backgrounds, but with a shared passion for Indian heritage. THT's objectives are to help document, understand, appreciate, disseminate, and celebrate the various aspects of India's wonderful heritage. Through our monthly heritage talks, we offer a platform for the expert and the well-informed enthusiast alike to share their knowledge on a wide range of topics: history, archaeology, epigraphy, numismatics, art, temple architecture, and so on. We also conduct workshops for heritage lovers. Some of them are how to see a temple, the Mallai study tour, and the short course on Pallava Grantha, and so on. During Chennai's famous music season, or Kacheri season, we conduct a Pechu Kacheri, that is a concert of talks. This is a 2-day seminar that takes an in-depth look at a chosen theme of history or heritage. Another popular THT initiative is the annual Site Seminar, a week-long visit to places of historical importance where every participant is expected to be both a student and a teacher. THT has also instituted the Tamil Heritage Trust Professor Swaminathan Heritage Award to recognize individuals who do significant work in deepening our knowledge of our rich heritage and widening the audience for heritage appreciation. Through the Indology Festival, we at THT want to celebrate not only India's culture and cultural artifacts, but also the scholars who study them. With popular interest in our heritage growing rapidly, so does the need for scholarship in a range of subjects and disciplines of Indology. This festival is our humble attempt to bring together experts from across the world to a heritage-loving audience in India and abroad. On behalf of Tamil Heritage Trust, I would like to thank each and every one of our speakers who has so graciously and readily accepted our invitation to speak at this event. We want our audiences to savor the taste of a sumptuous menu of ideas from many subjects. We have included prehistory, early history, mathematics, art, and architecture among the topics. We also have a session on heritage conservation and a panel discussion on heritage communication. In addition, the festival features contests that marry your interest in heritage with your passion for writing, blogging, or making short videos. We've been receiving entries for the contest, and the winners will be announced later in the week. Every day, the program will start at 7 p.m. There will be 2 back-to-back talks by the expert speakers. The talks will be followed by a discussion moderated by the program chair. The speakers will then take questions from the audience. We request the audience to type in their questions in the chat box of the YouTube channel. Ladies and gentlemen, we're all set for another evening of ideas and insights. We hope you enjoy the program, and thank you once again for joining us today. Before I hand you over to the program chair, it's my pleasure to introduce him to you. Badri Seshadri graduated from IIT Madras and then did a PhD in mechanical engineering from Cornell University, USA. He was one of the co-founders and later director of strategy and operations of the widely popular website crickinfo.com. Badri is an entrepreneur who runs a publishing house and a software consulting enterprise. Badri has a wide range of interests. He is a sought-after commentator on TV where he shares his analysis and insights into politics and current affairs. He conducts short courses for beginners in ancient Indian mathematics. He gives talks on temple architecture and iconography and much more. Badri is also a co-founder of Tamil Heritage Trust. So over to Dr. Badri Seshadri.
Welcome everyone to Tamil Heritage Trust Indology Festival. It's my pleasure to invite you for this exciting day, which will be on prehistory and early history, which has a lot of unanswered questions, and today's speakers will try to answer some of those questions. We have 2 speakers today who will be talking about the script of the Indus Valley civilization, which still has not been unraveled. And the other big question is that we have had so many people who have come to India, what we call today as the Indian landscape from different places. They have migrated. Who were they? What did they do? Obviously, we call it prehistory because nothing much has been written about. But if nothing is written, can we still find out more about them? Now, that is also something that we are going to see today, which is particularly about the geographical and prehistoric cultural subdivisions of the Indian subcontinent. Let's go to each of the talks. The first talk will be presented by Professor Rajesh Rao. He will be presenting about the script of the Indus Valley civilization, computational analysis and recent interpretation. A brief introduction about Dr. Rajesh Rao. He is the C.J. and Elizabeth Hwang Professor, Paul G. Allen School of Computer Science and Engineering at University of Washington, Seattle. He is a co-director of the Center for Neurotechnology. He is an adjunct professor in the Bioengineering department. He's a faculty member in the Neuroscience graduate program at University of Washington. He's also the director of Neural Systems Laboratory. Various awards that he has received includes Guggenheim Fellowship, Fulbright Scholar Award, National Science Foundation Career Award, ONR Young Investigator Award, Sloan Faculty Fellowship, David and Lucille Packard Fellowship. Along with his interest in neurotechnology, which is his current major interest, Professor Rajesh Rao has spent considerable time on the script of the Indus Valley civilization, and he has collaborated with one of the greats in this field, Dr. Airavathan Mahadevan. Let's look at a brief abstract of what Dr. Rajesh Rao will be presenting. We are all aware that nearly around 4,000 years back, and a little older than that, people who were living in what is now Pakistan and northwestern India, that's the region that we call as the region for Indus Valley Civilization, IVC. There, we have found short sequences of symbols on seals, tablets, pottery, and other artifacts. These Indus seals constitute, all these things put together constitute Indus script. It's one of the last major undeciphered scripts of the ancient world. We still don't know exactly what is there in it. Deciphering this has significant ramifications for the way in which we view the prehistory of Indian subcontinent. Dr. Rajesh Rao will focus on the research aimed at analyzing the Indus script using computational and statistical techniques. This kind of an analysis does not address the issue of interpreting the symbols, but will try to bring out the syntax of the script and allows a comparison with other scripts that are encoding natural languages. His talk will also focus on the constraints imposed by the syntax and artifact use could suggest possible interpretation. For example, he will talk about the class of fish symbols in the script. Most of the Indus seals carry the fish symbol. He would look at what this could mean, and from there on, drawing forth, there could possibly be interpretations on what these Indus seals may mean with respect to trade. Are they, in some sense, some kind of a monetary system, like a pre-coinage system for economic transaction, allowing for rapid generation of tokens, tablets, sealings, etc., to facilitate exchange of certain fixed amounts of goods, grains, animals, and labor. So this talk will focus on the script, bring about a certain understanding of how to interpret the syntax, and also come up with certain interpretations related to what those seals themselves could mean. So that will be the first talk for us. I welcome all of you once again to this talk, and we will move on to the first talk, which will be presented by Dr. Rajesh Rao.
Hello everyone, my name is Rajesh Rao. I'm a professor at the University of Washington in Seattle, And I want to take you on a journey to a 4,000-year-old civilization and talk a little bit about our efforts to understand the script of the civilization. So 4,000 years ago, there were famous civilizations such as the Egyptian civilization and the Mesopotamian civilizations. As most people know, the Egyptians were building great pyramids around this time. The Mesopotamians were also building ziggurats, and there were kings, there were wars, and so on. If you now move to what was happening in the South Asian area, there was also a civilization there. In fact, it was even larger in terms of the area than the Egyptian and Mesopotamian civilizations. It occupied almost 1 million square kilometers. And this civilization was the Indus civilization. It was basically flourishing around 2600 to 1900 BC. And some of the main sites are shown here, Harappa, Mohenjo-daro being the most prominent of them, and then Lothal and Mehrgarh being two others. And in the civilization, what's surprising is that despite the very large size, there is no archaeological evidence for any grand buildings such as pyramids or huge temples. There's even no evidence for these people building palaces, for kings and so on. What we have evidence for is very well laid out cities, which had amazing, sewer systems and water conservation systems. These systems would put, even some of our contemporary systems to shame. These people did not build, big palaces, but they did they did actually design these smaller objects. And so as you can see here, these are some of the iconic objects that you will see when people talk about the Indus civilization, also called the Harappan civilization. We actually do not know, who these people are. Is the person on the left a king, a priest, or a priest king? We don't know who the lady is in the middle. She's been called the dancing girl, and we don't know who the deity is. Looks like a horned deity, but we don't really know who that is. And unfortunately for us, we don't know anything about them because we have not been able to decipher their script. Yes, they did have a script. Here's an example of their script on these tiny seals. And as you can see, the seals have the script at the top, along with an iconic animal, in this case, this imaginary animal, a unicorn. But we actually have we actually do not know what these particular symbols mean. And these symbols are found not just on seals, but they're also found on, for example, copper tablets. They're found on pottery. And somewhat surprisingly, there's also one very large signboard that was found in the ancient Indus city of Dholavira in Gujarat. And again, despite being a large signboard, this particular, the inscription there is, again, not a very, very long inscription. That's one of the issues that we have in terms of deciphering the script. So the big question, of course, is, what do these symbols mean? Because if we can read these symbols, we'll learn more about this ancient civilization. This actually is one of the last major undeciphered scripts in the world. And so there's three different hypotheses that people have considered. The first one, which is a provocative one, is that the script does not even encode any language. So the idea here is that the symbols in the script are analogous to the symbols you find in shields, for example, or symbols that you use for indicating things like traffic signs and so on. A second hypothesis is that the Indus script encodes an Indo-European language. So if you look at this map of India, you'll see that most of North India, as well as East and Central India, the language spoken in those regions of India constitute are part of the family of Indo-European languages. And then finally, the third hypothesis is that the language encoded by the Indus script, the Indus people perhaps spoke a Dravidian language. So if you look at the map of India today, what you'll see is that the languages in South India, for example, Telugu, Kannada, and Tamil, they're part of the family of Dravidian languages. And then, interestingly, if you look up north towards Baluchistan, in current present-day Pakistan, you'll find a large group of people who actually speak a Dravidian language called Brahui, and that's somewhat surprising, and that's led people to suggest perhaps the Indus people were also, speaking Dravidian languages. So which of these, three hypotheses is correct? So one of the issues, of course, three of the issues I would talk about here, three issues that come up when you try to decipher the Indus script, is that first, there is no Rosetta Stone for the Indus script. So by Rosetta Stone, we mean that an artifact that contains an inscription in the Indus script, as well as the same content in a different script that has been deciphered. For example, the Sumerian, the cuneiform script and the Indus script. There is no such artifact, or at least they have not been. No artifact has been discovered yet that's analogous to the Egyptian Rosetta Stone that was instrumental in deciphering the Egyptian hieroglyphics. Secondly, as we've just talked about, we don't really know what language the Indus people spoke. And finally, also, as I alluded to earlier, most of the texts, pretty much all the texts actually that we have that have come down to us through the ages, these texts are all very short texts. So texts that are on average maybe 4, 5, or 6 symbols long, and these are typically on, as I said, these seals or tablets. So one thing we can do, though, is even if we cannot decipher the script yet, one thing we could do is start to understand things like the syntax and also, in this case, direction of writing. So, for example, if you look at these two impressions of seals, the seals are actually, they show the reverse image, and this is the impression of each of the seals. What you'll see is that on the left-hand side, there is a compression. It's as if the scribe who was writing the symbols of the script here ran out of space, and therefore had to either compress the symbols on the left-hand side, or even put one of the symbols down below because they ran out of space. So this suggests that the direction of writing is actually right to left. And there's actually more than just this piece of evidence. There's also evidence from pottery. In pottery, people have shown that if you look at the inscriptions that are on pottery, you can see that some of the symbols that have been written on the right-hand side have been overwritten by another symbol, the next symbol on the left-hand side, which again suggests that the direction of writing was from right to left. What other things can we do besides just trying to, before we actually decipher the script? One thing we did was to look at patterns in the Indus script. So let's start by looking at patterns in language. So if I give you the letter Q, the symbol or the letter Q in the English language, what would you predict is the next symbol? So if you think about this, this is something that anybody who has learned English can predict, right? Most of you probably predict the letter U. So Q is typically followed by the letter U. And now if I ask you to predict the next letter, now you have several choices, right? So you may have predicted, for example, the letter I, so QI, QUI, and then you have quiet, and then you have quick and quiet and so on. The other possibility for Q and U, the next letter would be E, for example. So you would have queen or queer or quell, for example. One thing that you will not do is to predict something like the letter B, right? So you wouldn't say that the next letter would be a B or a C or a D. And so the question you might ask then is, what about the Indus script, right? So if you look at the Indus script, you'll see a similar kind of pattern. So if you look at all the texts that we have now of the Indus script, many of the inscriptions, the texts, they start off with a symbol such as this diamond-shaped symbol. And this is typically followed by these quotation marks like symbol. And then after this, this sort of a prefix, what you find is a cluster of symbols that have signs such as these fish-looking signs. So if you look at this sign, it looks like a vertical fish-like sign, followed by other symbols as shown here. What you will not find is this particular quotation marks like symbol being followed by, for example, these human-like sign or an arrow sign and so on. And then finally, there's also very typical enders. So ending the text are these symbols. For example, this symbol is called a terminal sign. So this symbol looks like a jar, like a double-rimmed jar. So this jar sign is also one of the most frequently occurring signs in all the texts that we have so far. So this seems to suggest that there is some kind of regularity. There's some kind of a pattern also in the Indus script. So what we did, we wanted to quantify the patterns. So what kinds of regularities are there in the Indus script? So we used a computer to learn a statistical model. So this kind of a statistical model is also called a Markov model, where we use the computer to essentially count the kind of frequencies of what symbols follow a given symbol. So we're essentially looking at the probabilities of each of the symbols that can follow a particular symbol. And once we've done that, then we have a quantitative model of the sequential structure, you can say, of the Indus script. So what do we do with that? So once we have a model, a computer model, what can we do with that? So for example, if you had a monkey typing on a keyboard, right? So you might end up with some garbled set of letters that look something like this, right? So if you now quantify the amount of randomness, right? So you're looking at the probability of symbols following a particular symbol. In this case, in these kinds of random sequences, any symbol can follow any other symbol. So the entropy, right, is very high. So entropy is a quantitative measure of the amount of randomness in strings. And so we can say that this kind of a string where you have any symbol could follow any other symbol has a very high entropy. Now, at the other extreme, if you have, for example, the case where, this has happened to me too, where you sometimes, as you're typing, you may have dozed off, for example, and you have your finger on a key and it just repeats the same letter, right? So in this case, it's a highly regular set of highly regular string, and there is no quote unquote randomness right here. So in this case, as you might have guessed, this kind of a rigid sequence has very low entropy. So these kinds of strings would have very low entropy. Now, what about languages, right? So scripts that encode languages. Well, as you might have guessed, languages, scripts that encode language have an intermediate level of entropy. So they're neither highly random nor are they very, very rigid. So they're right in the middle somewhere. So now you can ask the question, what about the Indus script, right? So this is where our computer model comes in. So we used our computer model and we applied it not just to the Indus script, but we also used it to quantify the entropy of many different kinds of scripts and strings. And here's the result. So as you can see, at the very top, as you look at the very top, you have very high entropy here. You have very low entropy at the bottom, and that's the y-axis here. So it's plotting the normalized block entropy, which is the entropy of strings of increasing lengths. On the x-axis here is the sequence length. So sequences of length 1, 2, 3, 4, 5. So you're increasing the length of the string, and you're asking, if you look at all the strings of that particular length, that set of all strings, how much is the entropy, or how much is the amount of randomness? And the main result that we got was to show that the Indus script, so the amount of randomness or regularity in the Indus script falls right in the set of all the linguistic scripts. So, for example, scripts that encode Tamil, English, Sanskrit, Tagalog, Sumerian, the cuneiform script in this case. So they're all right in the middle. They have intermediate levels of entropy as you increase the length of the sequence. Whereas if you look at other strings like DNA and proteins, so sequences of DNA and proteins, you'll see that they have very, very high entropy. So they have a lot more randomness or flexibility in terms of what symbol can follow what a given symbol. Interestingly, a computer program, this was actually a Fortran program, so nobody uses Fortran anymore, but you can still compute the entropy of these programs. And so what you find there is that it's actually a little less. So the entropy of computer programs is a little less. So it's more rigid, I guess is another way to look at it, than the linguistic scripts. So So one other thing you can do with this computer model that we have is to look at patterns of things that are unusual. So for example, just to draw an analogy here, if I give you a sentence in the English alphabet, so all human beings are born free and equal in dignity and rights. So that's been translated here, and this is the same content, but in Dutch. So it uses the same letters of the alphabet, but what you'll notice if you do not know Dutch is you will think that some of these combinations of symbols are very, very unusual, right? And that's natural because you have not learned Dutch. So interestingly, our computer model detects that certain strings or certain texts are actually quite unusual in the sense that they have a very low probability of being generated by the computer model that we learned from the text. And why is that? Well, for example, in this case, if you look at the very first text, what you'll find is that it repeats this most commonly occurring sign, this jar sign, which typically ends an Indus text. In this case, it's repeated. So there's one jar sign following the other, and this never happens, almost never happens in the Indus text. Similarly, for the other one, also there are very unusual patterns in terms of what symbol follows a given symbol. And so it turns out that these texts were actually not discovered in the Indus Valley. They were actually discovered in faraway lands. In fact, they were discovered in archaeological excavations in the Middle East. So, for example, in present-day Iraq. And so the underlying idea is, how come these seals ended up there, right? In fact, some of these seals even look very different, even though they use the same script. One of them is circular, the other is a cylinder seal that has been unrolled here. This is the impression of the seal. So they do look different, but they're using the same symbols, right? So what can we say here? So one of the things that I have not told you yet is that the Indus people were very, very enterprising. So the merchants of the Indus Valley were probably the very first kind of global traders in some sense, right? So they actually traded not just with other cities from their city, but they actually had trade going on with civilizations and people in the Persian Gulf, in Dilmun, which is present-day Bahrain, and also in the Mesopotamian civilization. And there's even written cuneiform texts that talk about a land called Meluha, which people think corresponds to the Indus civilization. And so one of the hypotheses here that our computer model suggests that people have also suggested before is that perhaps the Indus merchants were using their symbol system, their symbols to represent maybe a different language, a language that was useful in these other faraway lands where they were conducting trade. So the same script was perhaps being used to encode different languages. All right. So at this point in time, you might be wondering, is there any hope for actually reading these symbols, actually making sense of them, making sense of the meaning of these strings, these texts, right? So I'll just give you a brief overview of what we have found. This is not just the work that I've done or my collaborators have done, but even colleagues in the field of Indus script research. So one of the main methods that people have used to understand or gain or infer some meaning, right, or suggest meaning to some of the symbols is the rebus principle, right? So, for example, if I tell you to represent a word such as belief using pictures, how would you do that, right? So if you think about it, what are the pictures you can use to convey this very abstract word? The word belief is quite an abstract word, but perhaps you can represent it using pictures, right? So one solution, if you probably already thought of this, is to represent it as two pictures, so one of a bee and the other of a leaf. So you have bee leaf, which if somebody reads that, they would infer, okay, the word that the person meant was belief, right? So the rebus principle has been used by many ancient civilizations to essentially start off with pictures and then combine them. These are called logographs. Use them to represent particular objects, but then also to ultimately combine them to form words that are difficult to convey otherwise, right? So that's one of the precursors to actually coming up with the full script for language. So for the Indus script, we're left with the opposite problem, which is you see all these symbols that look like they're pictograms, or they look like they're these logograms, right? Look like symbols, like a fish and so on, or a jar, but we don't really know what they stand for. So how do we read a string that has these kinds of pictures? So the big question there, of course, is what language should we try? So here, if you're an English speaker, you would infer the word belief, but if you speak another language, you may not infer that particular word. So what language should we try? And that comes down to, again, the question of what language did the Indus people speak? And so going back to our, the two major contenders here, one is the possibility that the Indus script encodes an Indo-European language. And so if you look at present-day India, these are languages like Hindi, and so maybe perhaps the Indus script encodes Sanskrit, right, or maybe a Proto-Sanskrit language, and that's one hypothesis. So interestingly, this particular hypothesis, there's some recent data where a very large group of researchers, headed by researchers at Harvard University, showed that if you analyze ancient DNA from skeletons in many parts of South Asia and also Central Asia and so on, it seems that the DNA analysis seems to suggest that there was a migration of Indo-European language speakers, but that happened only after 2000 and probably 2000 to 1000 BCE is when they suggest that this happened. Whereas we've already seen that the Indus civilization flourished quite before that. So 2600 BCE or even before that, there's evidence for the Indus civilization. And so there seems to be a mismatch there in terms of the language when people may have been speaking that particular language versus when the Indus civilization flourished. The second hypothesis, as we already mentioned, is that perhaps the Indus people were speaking Dravidian languages. And so the hypothesis here is that there were people speaking Dravidian languages all over the Indian subcontinent, but then right now you only see them in pockets, such as Brahui in Balochistan in Pakistan, as well as in central India. You see pockets of Dravidian-speaking people, such as Gondi, and in the eastern part of India, Malto and Kuruk, and so on. So if this is a hypothesis you would like to entertain, then where does this lead us, right? So many researchers have actually tried to use the Dravidian hypothesis and try to interpret the symbols. So one of the most famous ones, I think, is the interpretation for the fish symbol. So here's an impression of an Indus seal. You can see that it has basically these tally marks, 7 of them, followed by the fish symbol. And these are examples of other fish symbols you'll see in the Indus text. So is there a way to interpret this fish pictogram using, for example, a Proto-Dravidian kind of reconstruction of language? And so one of the first people to suggest this was Father Henry Heras, back in 1953. And Father Henry Heras suggested that the Dravidian word for fish is mean in many Dravidian languages and also in Proto-Dravidian. And mean also sounds like the word for a star. And so he suggested that this combination of symbols of 6 strokes followed by a fish sign, if you read that in a Proto-Dravidian kind of language, it would stand for Aru mean. And that in turn is a word that we find was used if you look at Dravidian language, especially Tamil literature, you'll find that as a word being used for the star constellation Pleiades. And similarly, some early Russian researchers, led by Norsov, suggested that this sequence of symbols, so 6 followed by the fish sign, the jar sign, and the human sign, may stand for Arumin Kadalan, which is another very old word that you'll find in old Tamil literature for Skanda or Muruga, the god Muruga. So these are really intriguing suggestions, which seem to be something that perhaps you can build on. So you can ask, can we take this further, right? So this is a promising beginning. Can we take this further? So one of the leaders in the field, Asko Parpola, has suggested in his book, published in 1994, several other additional readings. So for example, 7 stars, as shown in this seal impression, he suggests stands for Yelumin, which is again, Yelu is 7. And Yelumin is again a word used to represent Saptarishi constellation, or the Ursa Major constellation. And this is again in old Tamil literature. Similarly, he suggests that when you have a little symbol on top of the fish sign, he interprets that as roof, and so that stands for Main, which is again a word that has been used for Saturn in old Dravidian languages. And then also when you have a dot inside the fish, he interprets that as Pottumin, which is again a star constellation, the Rohini star constellation, or Alpha Tauri. So these are all very intriguing. You might ask, okay, what does this have to do with seals, right? So the suggestion here that Parpola makes is that the seals represent, the inscriptions on the seals are all names. So names of the merchants, which is a typical kind of function of seals. And so they denote ownership of property. So when you stamp something, maybe they denote that the property belongs to a particular merchant. And so when the goods were sent from one city to another, or one merchant's place to another merchant's location, then they would have these stamps. And so it makes sense in terms of the names being what these inscriptions represent. And further, Asko Parpola says that a lot of South Indian names have to do also with horoscopes, and horoscopes in turn are based on the stars and so on. And so he makes that connection also in terms of why he thinks these symbols represent names that are based on horoscopes and astronomy. And so one of the problems with some of these interpretations is that they have to account for why there's particular patterns. Like, for example, these fish signs seem to cluster together, as shown in these examples over here. And so so the fish sign by itself is probably not going to represent a syllable, for example, like pa or ka, or things like that. And so because you can't really have them repeated multiple times with, if you have syllables such as that repeated, you might get pa, pi, pu, and so on, which doesn't really make sense in terms of linguistic constructs. In terms of Parpola's interpretation, he says perhaps they represent combinations of astral configurations or different constellations all put together in one name, which is potentially a possibility there. But there's a further problem also posed by the syntax of these fish signs. So these fish signs seem to obey a very rigid order. So for example, from right to left, anytime you have a particular symbol, such as the fish with these little appendages at the top, the ones on the left typically are never on the right side of that particular fish symbol. And so they tend to obey this particular rigid order. So how can we explain that? So an alternate hypothesis is that the fish signs are closely related or represent weights that are used in trade. And so if you look at the smaller Indus weights that have been found from archaeology of Indus sites, you can see that the weights are actually based on doubling. So you have weights that are 1, 2, 4, 8, 16, and so on of a particular unit weight. And so Steve Bonta suggested, going back to 1996, he suggested that the specific fish signs may stand for these units of weights. And so, for example, starting off with the basic fish sign is 1, and you go up to 2, 4, 8, 16, and so on. And one of the nice things about this particular representation is that it's a binary representation, which means that any weight can be written as a combination of fish signs without using any sign more than once. And so, for example, the weight 5 can be represented as A and C, which is 1 plus 4 is equal to 5. Similarly, 7 is 1 plus 2 plus 4. And so you have A, B, and C. So you can use these signs And again, the signs here, will obey the order of the fish signs, right? So that's another interesting, attractive attribute of this particular interpretation of the fish signs. And finally, if you think about it in terms of, for a transaction, when a merchant is weighing a particular, item, they basically may have weights that are only used once, and then you can combine them with other weights to get any particular number, any particular amount of weight that you want. And so so you basically put in the biggest weight first, and then the next weight, and next weight, and so on. You can add them all up. You get any particular weight that you want. So it's a very economical representation of weights. And there's further evidence for this also. So the later Indian weight system was also binary. Much later than the the Indus civilization. The weight system that was used was binary. It was actually based on the weight of a rati seed. And that particular weight system is also interestingly binary. And then more interestingly, the system of weights, in the ancient world, so going far from the Indus Valley to Dilmun, which is Bahrain, in the Sumerian civilization, Mesopotamia, in Egypt, there was a unit of weight known as the mina, and the mina was used in several of these civilizations. And of course, using the rebus, the fish sign that we read, we previously read that as mean, and you can see it's closely related to mina, right? So the unit of weight that was used in the ancient world. And so Brian Wells, who's another major researcher in the field, has suggested this particular set of weights that associate with each of the fish signs based on his analysis of the frequency of the fish signs and the frequency of weights. He suggests that the basic fish sign has a unit of 6.9 grams, and therefore you can have units such as this. So he interprets this slash as being a half, so half, and then 1/3, 1/4, and so on. Similarly, he suggests that the fish sign with a dot in the middle is actually twice the unit, and then 4 times would be the one with these 2 horns, like a horned fish, and so on. And so he's come up with this particular set of interpretations of fish sign to weights. So each fish sign has a particular weight associated with it. And interestingly, if you look at the unit that is twice the basic unit, 13.4 grams, it's actually very close to the 13.6 grams, which was an international standard in other civilizations like the Dilmun civilization, Ebla civilization in Syria, Egyptian civilization, and so on. They were using this particular unit, 13.6 grams, which is very close to the fish sign with the dot or the mark in the middle, which is what Brian Wells suggests corresponds to 13.4 grams. Finally, I'll end with some of the work that I've done trying to relate some of these ideas to the economics of the civilization. So as we already seen this particular impression of a seal before, many of these signs, the fish signs have tally marks or numerals in front of them. There's basically 7 is what you would infer from this set of tally marks. There's a whole bunch of other symbols also that have tally marks in front of them. For example, this symbol here, or this diamond-like symbol, this is actually a V-shaped symbol that looks like a jar, which is preceded by 4 tally marks, right? And so a bunch of these particular symbols, these particular texts were found in these miniature tablets, the 3-sided miniature tablets in the site of Harappa several years ago. And so one of the things that you can ask is, what can these tokens or these tablets be used for? Why were they generated? And many of them are replicated. They're not unique. So they're probably not just names, but they were replicated almost like currency or coins, right? And so if you draw the parallels with other contemporaneous civilizations like the Elamite civilization in Iran and the Sumerian civilization in Mesopotamia, what you'll see is that at the same time as the Indus people were using these miniature tablets and so on, these other civilizations were using tablets also, but more for accounting. So they were using it to count the rations that were being used for laborers and workers. So for example, here you can see these impressions that are made that look like tally marks followed by a jar sign. There are these symbols that look like grain, so stalk of grain like barley, for example, and also these kinds of marks that are like tally signs. And so basically, people have interpreted these proto-Elamite and proto-cuneiform tablets as encoding the amount of grain or measures of cereal, grain, oil, and things like that that were being used to provide to the laborers or worker who were engaged in work for a particular employer. And so the suggestion here is that perhaps these miniature tablets, these tokens, were essentially ration tokens or economic tokens that were helpful in the administration of labor. So for example, here, each of these would denote some particular measure, like a unit of measure, followed by the amount of how many units were being used or provided to a particular person. And in fact, interestingly, Brian Wells has shown that there are pots. So these are pots that are currently in Purana Killa in Delhi that were excavated from Harappa. And he's shown that the inscription on these pots actually have the similar kind of inscription as this tablet. So here's a tablet that has 3 followed by the jar sign. And similarly, this pot has 3, the numeral 3 followed by, or 3 tally marks followed by the jar sign. And some of these bigger ones have more of these tally marks. So the inference here is that these numbers denote volume, right? And so he came up with an estimate based on the size of these pots that the basic unit, this V-shaped sign or this jar sign, is a volumetric measure that is about 40 liters. So 40 liters is what he inferred this to be based on the size, the diameter and the height of these jars. And so our particular inscription here would correspond to essentially something like 120 liters. So that's kind of an accounting that one might be, the employer of a particular business might be taking into account and using these tablets to either give it to the laborers and the workers, or to retain it as an account of what happened. And so we suggest that the seals themselves are also perhaps an innovation, an Indus innovation, to make it more efficient, make this generation of economic tokens more efficient, instead of having to do it individually for each of these tokens by hand. Once you have a seal, you can essentially stamp and generate many tokens as you employ people. And so, for example, when you have something like this symbol, could be 3 measures of a porter type labor. So this is a person carrying goods on a stick. We even see this sometimes in Indian villages today. And so this could be encoding that kind of labor. Similarly, there may be these kinds of symbols here that look like stalks of grain. So it could be 4 measures of grain type, this particular grain type, or a different kind of grain, or a weight, as we already said. So this would be essentially quantifying 48.3 grams if you go with the reading for a particular fish symbol. And similarly, we've suggested that some of these other symbols could also denote different kinds of labor. So for example, the harrow and the man would be a farmer, or maybe there's this carter who pulls a cart. There may be this symbol, which looks like tongs, so could perhaps metalsmiths, and similarly, a bow and arrow could be related to hunting. But these are all, we got to admit that these are all still speculations. One interesting find that seems to suggest that this token idea might have some merit is the fact that a Japanese team has found these kinds of tokens in a site in the Kutch in India. And so you can see that essentially it's that the harrow and a man symbol and a single straight tally mark there. So and then there's holes in here suggesting that the person, or the laborer perhaps, or the merchant, was carrying them and had them all strung up. And so it's almost like they were carrying these around in a form of currency, or a set of tokens that could be used for potentially exchange of goods, or for buying goods and so on. I'll leave you with some final ideas, which is, if you look at longer sequences than the ones we've looked at in the last few slides, they seem to have a certain pattern. So what we typically find is that there's some set of symbols that are, you can look at them as prefixes. And then there seems to be a middle part, which we're calling it medial here, after some work that's been done by Brian Wells and Steve Bonta and Andreas Fultz and others. And so the medial part seems to contain clusters of fish signs and numerals and so on. And then finally, there's also a core part of it, which is where perhaps these are the nouns that are being counted or weighed and things like that. And finally, there's a terminal sign, which is typically this jar sign or an arrow sign and so on. So we can come up with a grammar. So we can come up with this kind of a grammar that tries to mimic the kinds of patterns that you see. So as you can see here, it's like a context-free grammar from a computer science point of view that generates a prefix symbol and a medial part, a core part, and a terminal part. And each of these can be any combination of these typical pairs of symbols or more than pairs of symbols. And then the medial part might generate, for example, a fish oval cluster or a fish numeral cluster. And each of those generates their corresponding sets of symbols. So this is basically a first attempt at trying to come up with a grammar that starts to generate some of these texts. And these kinds of texts, which have this kind of a pattern, are called patterned texts. So we're calling them patterned economic texts because they seem to be quantifying weights and numbers and so on. And we can actually start to interpret some of these patterned economic texts. So if you follow the analogy from the Proto-Elamite inscriptions, typically those inscriptions have a heading that's usually the function of the tablet, and there's also some part of the inscription that has the person or institution that is involved in issuing the rations, and then there's also the commodity, what kind of item is being issued, and also the number or quantity, right? So similarly, we suggest that the interpretation that we can give to a long sequence of Indus symbols could be that the prefix might be something like the institution, business, or landlord, family, person. The medial part typically might denote the number or quantity and measures. And then the core part would be the commodity, and then the terminal part is something about the function of the seal in terms of what the seal is being used for, or the token is being used for when it's being impressed onto a tablet, for example. And so these kinds of ideas, have been discussed in this paper down below, which you can find on my website. And finally, there's one particular set of texts. So the pattern texts are what we can quantify or characterize using this kind of grammatical rules. But there's also what are called complex texts. And these may actually encode linguistic constructs. That's because, for example, if you look at the Dolavira signboard, the Dolavira signboard does not have any numerals or fish symbols. And it has some interesting regularities here also, such as these sort of chakras like signs, these circular signs that look like wheels. And so the suggestion is that there are there's lots of these texts that are not characterized by this kind of a grammatical set of rules, and those might potentially denote linguistic constructs, which would also fit in with the, if you recall the graph that we had, that the Indus script seems to have regularities in it, and it seems to have regularities that are in line with linguistic scripts. So this particular set of texts would definitely benefit from further studies. So let me conclude by just showing you some of the kind of historical decipherments that we've had in the past. So the Egyptian hieroglyphics were deciphered in 1822. The Mesopotamian script, the cuneiform script, was deciphered in 1857. And the most recent one, the most major recent script that's been deciphered is the Mayan script in the 1950s. And then now we're in the 21st century, and we're still unable, or at least we don't have a very good idea of what the Indus script represents, what kind of language it represents. And so the Indus people are still silent in some sense. And so why is this important? So the Indus people are ancestors, and they're not just the ancestors of South Indians or North Indians or Pakistanis or even South Asians. The Indus civilization belongs to all of humanity. So I think it's our responsibility to collaborate across disciplines, across boundaries, both regional boundaries and national boundaries. We need to collaborate to decipher the script so that these people can speak to us again. I'll end with that. And here are some acknowledgements. I'd like to thank all my collaborators and all the great colleagues that I've interacted with. And also I'd like to pay special tribute to a colleague and collaborator of mine, Iravathan Mahadevan. So Iravathan Mahadevan was one of the pioneers in this field of Indus script decipherment. And so we miss him, but also we really value his contributions to the field. Thank you very much.
The second talk will be given by Dr. Ravi Korisettar. Professor Korisettar is a senior fellow of Indian Council of Historical Research, New Delhi. He is also the adjunct professor of National Institute of Advanced Studies, Bengaluru. He was formerly the professor of history and archaeology at Karnataka University, Dharwad, and he established the Robert Bruce Foote Sanganakallu Archaeological Museum at Bellary in Karnataka. Some of his major research contributions include geoarchaeological research in the Kaladgi Basin, excavation of Sanganakallu Neolithic site, and discovery of volcanic ash site at Jwalapuram near Banganapalli. The history of human settlement, his topic will be on geographical and prehistoric cultural subdivisions of the Indian subcontinent. The history of human settlement across Indian subcontinent since the lower Paleolithic times to the Neolithic Iron Age time period will be traced during this talk. Distinctive cultural provinces are associated with a network of geographical environments, which in turn are governed by the variation in the intensity of monsoon precipitation and rainfall across the subcontinent. Dr. Korisettar will focus on the spatio-temporal variation in the way human settlements or early cultures have developed, set in a geographical and environmental perspective. A lot of information have been gathered over the last few decades of archaeological research, though nothing much written, nothing written has obviously been found. But by analyzing, for example, the archaeobotanical and archaeozoological findings, it's possible to find out what kind of plants and animals were domesticated by these groups, what were native to India, what kind of exotic crops from Africa, Southwest Asia, East Asia have come into the Indian subcontinent. All of this can be clearly analyzed, and we can look at some kind of a chronology of Paleolithic cultures, understanding and identifying the indigenous development of early food production right across the entire Indian subcontinent. These two talks will be followed by a panel discussion involving both Dr. Korisettar and Dr. Rajesh Rao, which will cover not just the topics that they presented, but a little bit more than that, the entire prehistoric, early historic periods of Indian subcontinent.
Participating with a lecture on some of very interesting aspects of Indian geography and evolution of Indian culture through time. And I'm very happy to also note at this point of time that very recently we completed a week-long World Heritage Day celebrations. And also, incidentally, 1st December happens to be the foundation day of the Archaeological Survey of India, way back 159 years ago. And this is a very happy coincidence, both for Indology Festival as well as the anniversary of the ASI and so on. So it is to be considered a very, very happy coincidence in this record. I selected this particular topic in order to make educated commoner some of the geographical factors and also environmental factors that have played a very important role in governing the way in which prehistoric cultural evolution has occurred in this vast Indian subcontinent. This region is a continental scale landmass and aptly called a subcontinent, and this is the region which is located in the southern part of the Asian landmass, and so it is aptly called Southern Asia. But in the context of understanding prehistoric cultural developments, we would have to look at this large continental, subcontinental area as one geographical unit instead of considering the divided nature of the landscape in terms of Pakistan and several other SAARC nations that form part of the South Asian region. And that is why I thought we should look at this particular landmass from the perspective of its influence on the way in which life phase of our ancient societies have been changing through time, and how these ancient societies have been successful in adapting to diverse network of ecosystems across this vast Indian subcontinental landmass. As you can see here, it has a land frontier of about 15,200 kilometers and a sea frontier of about 7,500 kilometers. An area from north-south, the distance is about 3,000 and odd kilometers. East-west, it ranges from about 2,900 kilometers and so on. And the total area occupied by this landmass is equivalent to 3,267,500 kilometers squares. So such a vast landmass can never, at one point of time present uniform, evolution of prehistoric cultures. So there are these natural factors which have governed the way in which the cultural geography has also evolved through time. And so that is why I thought I should be able to identify these culture areas which can be identified because of various geographical factors, various environmental factors, as well as the kind of the present configuration of the Indian subcontinent with respect to continental area and the oceanic area, and how it has witnessed the evolution of the kind of climate that prevails over this landmass. And particularly during the last 10,000 years, we have been witnessing the monsoon circulation in terms of southwest monsoon as well as northeastern monsoon. And of course, the history of the monsoon prevailing over this area has been very, very ancient. It goes back to nearly 15 million years or so. Whereas the history of mankind in the Indian subcontinent is not that ancient, as we can understand very easily. And so what we see here, we come across some of these basic terms when we discuss about the prehistoric culture, biocultural evolution, and the natural environmental factors that have played a role in the formation of these cultures, which are distinct to the Indian subcontinent. And India is one of the oldest land masses geologically, but otherwise also in terms of evidence for human occupation in this area. It is called part of the old world, where we have the earliest settlements in three contiguous continental areas like Africa, Europe, and Asia. And the Indian subcontinent, as we see, is part of the larger Asian landmass and so on. So in all these three continents, we have the earliest evidence of human evolution, very well preserved in African continent, and also well established geochronology for the earliest stages of human biocultural evolution and so on. And so as a result, we have very clear idea of the source region of present-day Indian populations. And then the antiquity of the expansion of these populations out of Africa into other parts of the world, particularly the adjacent regions in the early stages, and then going beyond these three continental areas across the oceanic region, and then enter into this new world, which are identified based on recent colonization of human populations of these land masses like Australia, the Americas, and then some of these as island nations that, and some of them are yet to be colonized by humans, as we know. We come across some of these terms because quaternary chronology plays a very important role in our understanding of the way in which human biocultural evolution occurred in one part of the old world, and then gradually expanded beyond this particular region into the neighboring areas and so on and so forth. So this term called quaternary refers to a geological time period, which is the fourth stage in the history of the Earth, and that is constrained by these radiometric dates beginning from about 2.6 million years ago to the present. Quaternary includes even the present, but this has been subdivided into epochs such as Pleistocene, Holocene, and Anthropocene. The Pleistocene, as we can understand, begins by about 2.6 million years ago, and then comes to an end around 12 to 10,000 years ago. And then recently, we have this particular term being discussed among various natural scientists, archaeologists, anthropologists, and several others who consider that we have entered this particular phase of history of the earth called Anthropocene. It is being debated where to begin the Anthropocene, and of course there is a general consensus, as we see in the literature, that somewhere around 1960s onwards the Anthropocene has been dominated by the way in which humans have been exerting their influence on natural environment and so on and so forth. And further, during the Quaternary, the Pleistocene and Holocene are further subdivided because we do have very good chronological control on these subdivisions. As I said, lower Pleistocene should certainly begin at 2.6 million years ago, and that also marks the beginning or the base of the Quaternary period. And then based on geomagnetic polarity stratigraphy, it has been subdivided into lower Pleistocene, middle Pleistocene, late Pleistocene, and so on. See, the lower Pleistocene time span is from about 2.6 million years ago to 0.7 million years ago. From 0.7 million years ago to about 1,25,000 years ago, this time span marks the middle Pleistocene, and then the post 1,25,000 years ago to the present, or up to 12,000 years ago, is later Pleistocene. The end of the Pleistocene is marked by the beginning of the Holocene time period. According to some time scales, we have 12,000 as the base of the Holocene, and according to some other time scales, we have 10,000 as the base of the Holocene. However, 12,000 appears to be more a consensus time for the beginning of the Holocene. Even here, the Holocene, although last 12,000 years or 10,000 years time period, has also been subdivided into early, middle, and late Holocene. Early Holocene from 12,000 to 6,000 years ago, middle Pleistocene from 6,000 to 4,000 years ago, and then late Pleistocene 4,000 years ago onwards. And these are also subdivisions based on some climatic changes which have occurred. These are short-term climatic changes, and as we can understand in the context of the Indian subcontinent, these are short-term climatic changes associated with the variation in the amount of monsoon precipitation, either during the southwestern season or during the northeastern season, and so on. So this rainfall across the Indian subcontinent has certainly governed the way in which the people living in this area in this particular landmass have been successful in adapting and then developing through time and reaching the present status of a civilization that we are all part of. And then we have these oldest settlements known from the Indian subcontinent. And there is also diversity in the way in which we see the distribution of this kind of earliest lower Paleolithic settlements. They are also part of the lower Pleistocene, as I mentioned previously. And the oldest known lower Paleolithic settlements are widely distributed in the subcontinent. Two broad regions can be identified here. The northwestern part of the Indian subcontinent and the sub-Himalayan region of the northwestern part of the Indian subcontinent of the present Pakistan. We have what is called the Potawar Plateau. In the Potawar Plateau, we have these British archaeological mission to Pakistan in the 1980s, identified some artifactual assemblages from geological contexts, particularly at the sites called Pubby Hills and Rivat, and the paleomagnetic chronology for the deposits in which some of the artifacts were found. They are non-diagnostic, unlike the ones which are shown in this particular slide. They are now being dated to 2.2 to 1.8 million years ago. They stand in isolation because the subsequent research has not contributed to identifying many similar sites occurring in the neighborhood of these two regions or elsewhere in the Potawar region or in the Indian sub-Himalayas and so on. But they remain in solitude. But yet, since they have been published, very well published, in specialist journals, and so we have to recognize these two sites as representing the earliest phase of human settlements in the Indian subcontinent. But however, some of the sites in Tamil Nadu, such as Athirampakam and Isampur in Karnataka, are now very well dated. And during the last 20 years or so, there has been a considerable progress in the way in which we have been able to establish geochronology of the context of these early Paleolithic, assemblages, and dated by modern, absolute chronometric methods. So as a result, we now have a clear picture of the presence of human settlements, oldest human settlements, more or less, same time as in Africa, but not as old as those in Africa, but with a spatial lag is a temporal about 10,000 to 20,000 years or so. But it needs to be still ascertained. But these two sites have given us a time range for the earliest settlements in the Indian subcontinent associated with this kind of Acheulean assemblages. They have been found not only in Africa, elsewhere across the old world, like Europe and major part of Asia and so on. So some of these Rivat and Pubby Hill sites, have displayed the presence of non-diagnostic artifacts, because these are very well recognized earliest stone artifacts found across a large geographical area, not only in Africa, Europe, and Asia, and so on. And they are now also being reported from eastern part of Asia, like China, Korea, and then of course, northern parts of China as well. But there are certain issues, in assigning cultural status to these very ancient settlements that have been found outside of Africa. But well-established evidence of the presence of Acheulean lower Paleolithic bifaces, these are called bifaces, have been associated with the Homo erectus populations who evolved in Africa around 2 million years ago. As of now, we have that date for the Homo erectus going back to about 2 million years. Until recently, it was thought that Homo erectus evolved in Africa around 1.8 million years or so. But then the advanced research and revisiting of some of these say ancient sites in Africa have been adding to greater and greater time depth to these early sites and so on. And that is why Africa remains the source region of all populations living outside of Africa. And so these two sites also are very, very important to ascertain the fact that India, being part of the larger Asian landmass, also was favorable for human expansion as early as lower Pleistocene or lower part of the Pleistocene, from about 1.8 million years ago onwards. But majority of the sites where we have the assemblages of this type of stone artifacts are in the time range of about 800 to 300, 400,000 years ago onwards. So, but yet these are some of the very good clues for further research into the early human occupation of the Indian subcontinent. And as I mentioned, these are younger than those sites in Africa and mark the early colonization. This term is very, very popular among archaeologists and paleoanthropologists because it has been very well established based on biocultural evidence from Africa that that region happens to be the source region of all human populations, either at this particular stage or at a later stage, which we associate with the expansion of modern human population, modern hominins, anatomically modern humans, even expanding out of Africa and so on. This phase is associated with what we call the Middle Paleolithic, and this is characterized by the production of small implements, and they are basically flake tools, unlike those larger flakes and then the tools which were made from pebbles and cobbles and so on. Here there is a particular emphasis on producing stone artifacts by producing flakes from cores and then modifying these flakes into various types of scrapers, borers, notches, and points, and so on. And there, here again, we have one site in Tamil Nadu, that is Athirampakkam, which has given us the earliest date for the Lower Paleolithic in India, also gives us the earliest date for the Middle Paleolithic in India, going back to 395,000 years ago. And it has a temporal span of about, ranging from 395,000 to 172,000 years ago at Athirampakkam. But at other sites in different parts of peninsular India, we do have the continuation of the Middle Paleolithic tradition going up to 50,000 years ago and so on. Following this, we have this particular tendency towards producing blades instead of flakes. Flakes are amorphous, whereas blades are parallel-sided, well-defined, narrow, elongated flakes, which also have been detached from cores, and then these blades were also retouched into various types: points, borers, denticulates. Then you have choppers. Sometimes you do have heavy duty tools accompanying them, and then these are called levalva flakes, and then points, and then including the bone artifacts. You have varieties of these engravers, we call them burins. And here is the situation where we find not only the archaeological context revealing lithic assemblages, but also bone artifacts, and also evidence of art activity that is very, very frequent at a number of these upper Paleolithic sites, not only in India, elsewhere in the world. And then this particular period, Upper Paleolithic, comes to an end by about 12,000 years ago. And between 12,000 years and 10,000 years ago, at a number of sites, we come across a distinctive, elongated, diminutive blades when compared with those produced during the Upper Paleolithic. They are narrower, and they were also made from an entirely different type of lithic raw material we call cryptocrystalline silica, vitreous, textured rocks like chalcedony, agate, jasper, and so on, which was ideal for producing microlithic blades and so on. And these microlithic blades were comparable were comparable to those which are very, very common in the Mesolithic time period. But between 12 and 10,000 years ago, we have some of these epipaleolithic assemblages which are preserved as part of the uppermost sediment layer along the river sections that have been observed. But of course, this raw material was already chalcedony, jasper, agate, and such cryptocrystalline silica raw materials and so on. Following this Mesolithic period, the early Holocene witnesses the emergence of Mesolithic way of life. These are all again hunter-gatherers, but they were now getting exposed to larger geographical areas following the end of the Ice Age. The Pleistocene was characterized by a series of cold and dry periods, with intervening warm and humid periods. And these have been now identified as marine isotopic stages. Odd-numbered isotopic stages refer to warm and humid conditions like we have experiencing today. And even number isotopic stages are characterized by cold and dry conditions. So during the last 2 million years, as many as 18 to 20 isotopic cycles have been identified from the marine sediment cores, and that has become the standard for correlating the cultural developments with these climatic events and so on. So Mesolithic and post-Mesolithic cultures such as Neolithic and Chalcolithic, and then we have Bronze Age and Iron Age cultures rapidly evolving during the last 10,000 years, and they were the most successful of human society so far the planet has witnessed. Now, if you look at this particular map, you come across a large number of sites distributed, shown by these symbols here, occurring across major part of the Indian subcontinent. The legions that are shown here refer to the well-investigated sites. It does not mean these are the only sites that we know from the Indian subcontinent, but there are many more. And in particular, this is the map of the present India, where we have sites ranging from sub-Himalayas to the modern, Thar Desert to western part of, the peninsula, that is Saurashtra Peninsula and Kutch area and so on, central India, the northern Deccan and southern Deccan and so on. The well-known sites like Atirampakkam are here in the northern Tamil Nadu region. And then we have several other sites like Isampur and all coming from this region. These are the well-dated sites we have. But yet, what I would like you to notice is the absence of some of these sites in these geographical areas. Either it is in the Ganga Valley or further westwards into the plains of the Indus, and further westwards into the Balochistan, Sulaiman, Kirtar mountain ranges up to Karakoram and so on. So there is a differential distribution of these sites. So what we see here is that there are some geographical factors which may have played an important role in controlling the spatial distribution of these early hominin populations across the Indian Peninsula. As you can see here, during the early Holocene, during the Holocene, cultural transformations were more rapid than during the Pleistocene. We see a kind of stasis in the lower Paleolithic, ranging in time from 1.8 million years to almost 400,000 years ago. And then the post-Acheulean, the middle Paleolithic has only a time span of about 350,000 years ago. Upper Paleolithic, rapid transformation happens from about 50,000 years ago to 12,000 years ago, and so on. But here, in the last 10,000 years, the cultural transformations have been very, very rapid, and so on. This period witnessed the Neolithic and Bronze Age revolutions that laid the basis for the gradual emergence of literate or historical societies. And I should also mention at this point that the Indian subcontinent is one of the unique geographical areas in the world which has witnessed the emergence of two civilizations. And why these two civilizations? Whether the first civilization, what was its areal extent, and whether it occupied the entire Indian subcontinent or it was geographically restricted. I know it was. We all know that it was geographically restricted. And the second urbanization that rose in the Ganga Valley, in the middle Ganga Valley, about 2,500 years ago or 600 BC onwards, as now it is perhaps the longest civilization this particular land has witnessed, and this is the most successful phase of human biocultural adaptations to this particular Indian subcontinental geographical environment and climatic regimes prevailing over this area, and so on. Although many of these early classical civilizations or the early civilizations like the Nile Valley civilization and the Mesopotamian civilizations, or the gift of these major rivers like the Nile and the Euphrates, Tigris and Euphrates and so on, in the Indian subcontinent, the Indus Valley civilization may have come up along the Indus and its major tributaries and so on. Whereas the second urbanization that began about 600 BC, and that is the time when that marks the beginning of Iron Age in the Indian subcontinent, it is not restricted to the river valleys alone. So the expansion of this second urbanization was not governed by the network of these drainage systems across the Indian subcontinent, but by the prevailing monsoon circulations across the Indian subcontinent. So it may be appropriate to identify the Indian civilization as a monsoon civilization rather than a civilization which is gift of these major rivers like the Indus Valley or the Tigris, Euphrates Valley or the Nile Valley and so on. So this period also witnessed the emergence of local early agricultural traditions. This needs to be emphasized here because in order to understand the later, development of unity in diversity, if we go backwards in time, we see this localization playing an important role in the emergence of agricultural way of life in the Indian subcontinent. Similar situation was also observed in the rise of Indus Valley civilization. There is a localization there, and then there is a integration era and so on. So integration gave rise to a kind of a situation where you have a multicultural civilization and so on. Here again, the present Indian civilization is a multicultural civilization. It is an amalgam of several regional cultures, and then over a period of time, these regionalities that one observes in the Neolithic provinces across the subcontinent were gradually erased, and then we have a wide expanse of Iron Age cultures flourishing across the Indian subcontinent and so on. See, the rise of agricultural way of life characterized by local traditions shows spatial variation in the timing of their emergence, which I will show you gradually, and were gradually integrated into one another, giving rise to cultural unity and diversity as revealed by the diverse archaeological data sets supported by absolute chronological framework. Now let us look at some of the local role of geographical and environmental factors governing the emergence of regional cultures and so on. So if you look at these physiographic features of the Indian subcontinent, you have this particular configuration. In the north, you have this large frontier, as I mentioned earlier, is separated from Northern Asia by this Tibetan and the Himalayan plateau, and that prevents the flow of severe winter winds to North India. So that is why the winters in Northern India are called warm winters. So this Tibetan plateau prevents the onset of these cold winds from Siberia, severe cold winds from Siberia. And then you have this particular Balochistan mountain range, which also has given a distinctive, geographical boundary between Southwest Asia here and the main Indian landmass and so on. You have this coastal landmass stretching for well over 7,500 kilometers, and even this particular coastal seaboard has played a very very important role in integrating cultures, regional cultures, not only within the Indian subcontinent but also from across the oceanic areas. So as early as about 2,500 years BC, or 5,000 years ago, we see certain small-scale societies living along the coastal regions of the Indian peninsula playing an important role as seafarers. And this seafaring activity of these small-scale societies led to introduction of various types of food crops from outside the Indian subcontinent, tree crops from Southeast Asia, and at the same time also introducing some of the food crops that are part and parcel of Indian economy, subsistence economy, introduced beyond into Eastern Asia and Southeast Asia and so on. So this particular configuration, physiographic configuration, has played an important role in the onset of monsoon circulation over this area. The Tibet plays an anchoring role for the southwest monsoon, and during the summers, this continental area, this is the main peninsula, which is a northern peninsula, the Deccan Plateau, northern Deccan, southern Deccan, and the plains of Tamil Nadu. We have a narrow coastal land here, and then the deltaic land, area along the eastern coast, and so on. This Indus, Ganga, Brahmaputra plains are part of the extra peninsula. They gradually merge with the sub-Himalayas, lesser Himalayas, central Himalayas, and the trans-Himalayan Tibetan plateau, and so on. So this anchors the onset of the monsoon circulation. During the summers, the oceanic area gets heated up, it creates moisture, and then the continental area also gets heated up and creates a low pressure area, and the siphoning effect of the moisture accompanied by the trade winds coming from equatorial Pacific give rise to onset of monsoon reaching the southwestern part of the Indian peninsula, and then gradually moves across. And the Western Ghats come in the way in the smooth transmission of the monsoon precipitation from southwest to inland areas, and then get reflected and then move in a different transect during the northeast or winter months and so on. So the coastal area receives very high rainfall. The Western Ghats, they receive even higher rainfall, and then as one moves eastwards, you have ecosystems which are governed by lower precipitation regimes. So you have deciduous forest ecosystems, and major part of the inland region is covered by the grassland ecosystems and so on. So this variation in the ecosystems and the network of these, for example, the southwest monsoon hardly reaches this particular area, and so you have a hot desert prevailing in the northwestern part of this subcontinent. But what we know from archaeology is that this desert is not very, very ancient, because in the subsurface region, we have very, very early human settlements preserved in the desert sand, in the desertic regions of northwestern India today. So as we move further westwards, you are entering into the larger the Indus basin, and even here not many early settlements have been documented, because major part of archaeological inquiry has been focusing on understanding the rise and fall of the Indus civilization and so on. But those upland sites, like I mentioned in the Potwar Valley, like Pubby Hill and reward sites remain here, and a couple of sites of equal antiquity have also been found from Jammu area. But then they are isolated ones, but more consistent evidence and continuous evidence for human occupation from the earliest times to most recent times is very well present on this continental Indian peninsula. This is an upland area. This is Deccan Plateau or the Indian peninsula, the main Indian peninsula, bounded by Indo-Ganga Brahmaputra plains and sub-Himalayas and lesser Himalayas and so on. As one moves away from this particular zone, there is increasing absence of early settlements. So some of these areas were very, very potential areas for human colonization only during the last 10,000 years or so. So prior to 10,000 years ago, we have hardly come across sites belonging to the Pleistocene period. So is the case in some of the sub-Himalayan valleys and so on. But occasionally we do come across early settlements in modern Nepal and other areas. When one moves into the northeastern upland areas, this is an entirely different cultural zone, and there are more affiliations with further east and southeast of this particular region. And so we draw a blank when it comes to identifying the earliest settlements of the Paleolithic time period, whether it is lower Paleolithic, whether it is middle Paleolithic, whether upper Paleolithic, and so on. So this differential distribution of these various cultural settlements of various cultural time periods has been of some interest to me in order to understand why this differential distribution has occurred, why there is temporal variation in the way in which these cultural periods have flourished in different parts of the Indian subcontinent. And that is one reason why we thought some of these natural physiographic, topographic, groundwater resources and surface water resources and the precipitation regimes giving rise to a network of vegetation provinces, you see, may have played an important role in the way in which these early hominin populations were capable of adapting and then developing regional cultural traditions, and then gradually expanding their culture areas, and then giving rise to integration and then amalgamation, giving rise to erasing the kind of regional identities that one sees at some point of time as part of the Neolithic way of life, as part of the Bronze Age, and so on and so on. Since the Iron Age, the subcontinent has witnessed gradual integration of these regional cultures and giving rise to what we call cultural unity in diversity. This is reflected particularly in the food habits, as has been documented from archaeological research that has been going on during the last 150 years or more, and more so during the last 20-25 years or so. And so we have, in addition to that, the rainfall, as I mentioned, has played an important role in the rise of these vegetation provinces across, because these are also important for archaeologists to understand the habitability of the different parts of the Indian peninsula, because plant food resources played an important role, wild plant food resources, wild game, and then the availability of fresh water, perennial availability of freshwater resources, and also the availability of lithic raw materials, because during the Stone Age, the availability of suitable rocks played an important role in governing the location of these hunter-gatherer settlements across the Indian subcontinent. So there is as I mentioned earlier, precipitation regimes have been varying from the proximal area to the distal area. Major part of the Indian subcontinent receives rainfall during the summer months, and it is about 75% of the monsoon rain across the subcontinent, and the remaining 25% is part of the northeastern monsoon, which is now ongoing. And this part of peninsular South India is well covered by the northeast monsoon. And so, in the context of rain-fed agriculture, these two monsoon circulations played a very important role. And so, as can be seen in the way in which we celebrate harvest. So, in the absence of monsoon systems, the October month marked the one of the harvesting seasons, and in the month of January, the second harvesting season it marks the is seen across being part and parcel of the life phase of the people living in the region which is covered by the northeast monsoon area, and so on. Here again, these distinctive colors give us an idea of different types of vegetations governed by the precipitation regimes, and these are the regions which are the sources of various types of plant food resources, and so on. In addition to that, we also have to look at the geological framework of the Indian subcontinent, as characterized by these distinctive geological provinces. As we can see here, this is the Deccan Volcanic Province, and this is the region which is covered by the basement rocks such as granites, gneiss, condolites, charnokites, and so on. And then we have some of these basins which are shown by this yellowish color as called proterozoic basins. They are also Precambrian, the oldest part of the basement complex, but then they are distinctive in their lithological framework. And we also see various other regions which are covered by alluvial landforms, the vast alluvial plains of the Indus, Ganga, Brahmaputra, and so on. And some of these rock formations across the Indian peninsula have played a role in the availability of varieties of these raw materials, maybe raw materials for making stone artifacts, or precious and semi-precious stones for making objects of adornment, and your metals and minerals occurring across these region as part and parcel of the geological formations have played a very important role. And we see there is some kind of direct relationship between some of the later cultures and their ability to recognize the presence of multiple varieties of mineral metal resources and even ores occurring in these geological formations and so on. So the climate, the rainfall regimes, the forest, the vegetation provinces, and the geological provinces are very, very important factors in governing the way in which human habitation has occurred across the Indian peninsula during the last 2 million years or so. Here again, we come across the rainfall, vegetation, and the geological basis of this particular peninsula has also played a role, has also governed the formation of soils. So the black soils of the Deccan Volcanic Province are very rich soils, very fertile soils, and they are the ones which are suitable for produce agricultural production. And then you have poor sandy soils in the granitic and gneissic areas, and then relatively more richer soils are also found in some of these basins and so on. Now, these soils characteristics are also important in governing the way in which these some of these areas where we do not come across early settlements were later were attractive for these early agropastoral communities, gradually colonizing different parts of the peninsula, which were not previously colonized by hunter-gatherers and so on. So some of these areas are culture areas which prospered since about 10,000 years ago. And then some of these areas, like what we see here, is the Kadapa Basin, the Kalabgi, Bhima Basin, and the Vindhya Basin, and some of the Basta Basins, and then the Gondwana Basins in northern Tamil Nadu. They were the areas which favored early colonization, early expansion of human populations into those areas because of certain topographic and lithological features, as well as the availability of perennial water sources, because it is not only the monsoon precipitation which facilitated the availability of fresh water on land, but also the high water tables as we go backwards in time were playing very important role in the context of peculiar undulating topography, which has developed in different geological provinces, gave rise to spring activity. So inland areas were much more well watered than the areas which are covered by these major river systems and so on. We look at many of these rivers in the peninsula as seasonal streams, but in fact, as you go backwards in time, groundwater seepage into these channels was much higher than what we see, and this depletion of groundwater tables has caused the formation of these seasonal streams otherwise. So the present is not key to the past. So if we can understand the paleo environment of the distinctive geological and geographic provinces across the Indian subcontinent, we will be in a better position to interpret man-run relationships in prehistory and so on. Presently, what we see is governed by the variation in the monsoon precipitation. We have the savanna region stretching from this region in the northwest to the southern part of the peninsula, and this is one area where we see the emergence of agricultural, early agricultural, Neolithic and post-Neolithic, settlements, very well distributed, and then well adapted to the semi-arid grassland environments and so on. So we have this in the event of increase in the monsoon precipitation, this savanna land area will shrink, and in the event of decrease in the monsoon, precipitation, these savannas will expand. And this is peculiar, and this is also common to forest ecosystems and so on. So in response to these climatic long-term variations, forest areas have been expanding as well as contracting and so on. And that has also governed the way in which human settlements have been expanding, spatially expanding across the Indian peninsula and so on. Given the high precipitation regimes in the Western Ghats, you have this dense forest cover over the Western Ghats here, and they are the areas where you have varieties of plant species giving these medicinal plants, fruits and nuts and tubers and so on, jackfruits and then mangoes and variety of other plant food resources here. This is a dense forest, but honey gathering and forest dwellers have been exploiting these resources even today, and they are widespread along the tropical, high precipitation monsoon regions, not only in the Western Ghats and Eastern Ghats, but also in Sri Lanka and Southeastern Asia, that is the tropical region. And if you further move inland, you encounter tropical dry evergreen scrub woodland kind of an vegetation, many fruits, some nuts, many disjuncts from African savannas also occur here. Fewer tubers and then more grasses, wild millets. That is, the grasslands are very, very ideal regions to identify the presence of various types of millet, wild millets, which were later cultivated, and then the domesticated forms were developed, and then wild pulses, and then big game, hunting, gathering, and then gathering wild millets and then wild pulses could very successfully take place in some of these ecosystems that we see here. So mosaic with a savanna, reasonably well buffered, easily managed by seasonal firing, and then hunter-gatherers and moderate to high density populations in this area. Gradually, they were able to identify these resources and then adopt them for an agricultural way of life. So these are some of the examples of wild millets: Setaria verticillata, Brachiaria ramosa, or some of these millets which were first identified by these early agropastoral communities that were widespread during the late Holocene time period, from about 4,500 years ago onwards. They are also wild. That is one advantage, because these grasslands were very, very productive environments, and so these biomass was very, very favorable for transforming hunter-gatherers into early agriculturists, as well as herders and agriculturists, and so that is agro-pastoral communities and so on. And then further inland, as we go into heartland of the peninsular South India, you come across this kind of scrub savanna vegetation. This is tropical dry evergreen. Of course, this acacia and such other associated fauna, floral associations are very common in this area. And these regions are also rich in variety of lithic raw materials and then the spring activity. Because of this kind of undulating lands, we may call them uplands, or we may call them hill ranges and so on. But in the context of understanding man and relationship, these elevated land masses and the geological formations, which are interrelated, have given rise to formation of springs through these fissures and cracks within the geological formations. At times of high water tables, the groundwater flow was giving rise to formation of gentle flow of spring water down along the slopes and then accumulate in this area. Now this is a dry, low valley floor, but if you go back in time 5,000 years ago, 6,000 years ago, perhaps there were large perennial pools, and that is where we suspect inland areas were much more well watered than the fluvial network of rivers. And at the same time, you enter into deciduous, is a transition between tropical forests and grasslands. You have this, and deciduous forest systems are marginal environments where we have greater diverse variety of these plant food resources available for hunter-gatherers and early agropastoral communities as well. Now, as I mentioned in the beginning, we have these oldest dates for the East African sites. The settlements of the lower Paleolithic, they are referred to as Mode 1, and Mode 2 assemblages. As I said, we have some sites dating back to 1.8 to 2 million years ago in this region. And even in Africa, we have two lithic traditions identified as Mode 1 and Mode 2. They were otherwise known as Old 1 and then Acheulean. Acheulean are those bifaces, hand axes, cleavers, and Mode 1 are simple flake tools. So some such Mode 1 artifacts have been found. That is why I mentioned non-diagnostic artifacts have been found in the Potawar region. So indicating the possibility of human expansion earlier than about 1.8 million years ago. But what we need is more consistent evidence coming from this part of the Indian subcontinent. So similar sites characterized by the presence of non-diagnostic, early Paleolithic or Mode 1 assemblages, not only in this region but also in the middle latitude regions of southern Europe and also in Eastern Asia, has given rise to the possibility of what we call pre-Homo erectus expansion out of Africa. But the overwhelming evidence of early human occupation in the Indian subcontinent is associated with the emergence of Homo erectans and then gradual expansion beyond Africa into Southwest Asia and then Indian subcontinent and further eastwards into Southeast Asia and so on. So some of these sites, this is the way the colonization and the human expansion may have occurred in the past, and we do have clear evidence that as early as lower Pleistocene, first humans entered into this area. So hominin dispersals out of Africa into the Indian subcontinent. See, we look at the causes for the dispersal, especially biocultural and changing climatic conditions. And then the Paleolithic archaeology and geochronology have produced data sets which trace three major phases of human colonization of the Indian subcontinent. One is associated with out of Africa 1, that is expansion into Eurasia, riddled with conflict, because whether these expansion occurred as early as 2 million years ago or much later in time, around 700,000 years ago or so. But we now have a clear indication that it may have occurred as early as 2 million years ago or so. Out of Africa 2 is associated with modern humans or our immediate ancestors, who are also known as anatomically modern humans, and they are associated with Middle Stone Age or Middle Paleolithic that I showed you in the beginning. And then yet another phase of human expansion which may have occurred around 60 to 70,000 years ago. There are two arguments here, one associated with the invention of microlithic technology in Africa, and also the genetic ancient DNA studies that have been carried out in the recent past have indicated a recent expansion of modern humans into the Indian subcontinent and so on. We'll not get into these, but these three phases are now being discussed amongst paleoanthropologists and archaeologists and so on. So these varieties of categories of sites that we know from across the Indian peninsula occur in different in different categories. The open air categories are more dominant. We have some of these open air sites, like I was talking about, these northern Tamil Nadu sites around Athirampakkam and related sites in the Upper Gondwana, Alikuli, Alikuli hill ranges. Here they are called Upper Gondwanas. These formations contain ideal raw materials for making these Acheulean tools and even later Middle Paleolithic and Upper Paleolithic tools and so on. So in the last 20 years, this region very intense Paleolithic archaeological investigations have been going on. As I mentioned, two important dates have been obtained for the site. The first phase goes back to 1.8 and the second phase goes back to about 400,000 years ago, and both are giving scope for establishing an early chronology, or what we call long chronology, for colonization of the Indian subcontinent, so on. So these are some of the sites which have been reinvestigated in the recent past by Shanti Pappu and her team, and ongoing research is likely to bring to light many exciting and tantalizing results, such as the dates that we have in the last 10 years, and then a few more sites are being investigated belonging to Upper Paleolithic and so on. So we await more results from these ongoing investigations here. This is that particular site of Athirampakkam, where we have the lower Paleolithic as well as the Middle Paleolithic, which have been dated, very well dated by these radiometric methods. And then as we were talking about yet another site called Isampur, that is located in this particular region in northern Karnataka. This is part of a geological basin known as the Bhima Basin, where we have these limestone formations associated with sandstones, quartzites, and so on. But the kind of limestone we have is very hard variety of limestone, and that was very well suited for making these early lithic artifacts. But in addition to that, the environment of this particular region, this is part of the rocky desert of northern Karnataka. This is lies on the eastern margin, southeastern margin of the Deccan Volcanic Province. The Deccan Volcanic Province is younger than the basin that we see here, and these limestones are much older, and they are siliceous in nature. And this particular topography, like I showed you in one of the slides, also facilitated formation of perennial spring activity. As a result, this spring activity gave rise to gentle flow of water in the form of sheets, not in the form of channels, and that gave rise to this valley floor and the numerous pools and ponds, perennial spring activity, and sort of an oasis today. But you can imagine, several hundred thousands of years ago, this was much more luxurious, and providing a variety of plant and animal food resources. When you have sufficient water, you have vegetation prospering, and then when vegetation process, you have herbivores colonizing this area. When herbivores are there, you have predators colonizing this area, and naturally humans, their arrival is governed by the availability of suitable raw material, and hunter-gatherer adaptations took place into this particular region as early as 1.2 million years ago, and so on. And there is a continuous evidence of human occupation ranging in time from lower Pleistocene into modern times, and as many as 200 early Acheulean sites have been documented from the small area of about 500 square kilometer area. These are two small streams which are combining and then flowing into the larger river called the Krishna. But this is the basin area where we have widespread occurrence of these settlements, although they have been shown as part of the drainage network that we see here, but they were very much part and parcel of this kind of a landscape which was characterized by numerous springs as well as pools and ponds and so on. So this is a drainage map of modern times with which these archaeological sites have been shown. So one of the sites which we said it is about 1.2 million years is a quarry site, where we see that raw material was procured locally, and then it was subject to modification. The blocks of limestone were detached, and then the pyramidal flakes, large thick flakes, were detached from such blocks, detached from such kind of position, and then the flakes were modified into various types of hand axes and cleavers and so on. In another region where we have further eastwards of the southeastwards of the Hunsigi or the Bhima Basin, we enter into what we call Kurnool Basin. Here again, in an area of about 2,000 acres, we have this well-preserved evidence of cultural development from early Paleolithic to late Paleolithic, and then Neolithic and Iron Age, and even into modern times. So in this, he like at in the northern part of Tamil Nadu and in the Hunsigi Valley, even here, this particular topography also facilitated perennial water availability in the form of pools, ponds, and so on. And the springs were very, very luxurious here and gave rise to formation of a large lake-like situation, which has preserved evidence of human activity ranging in time from lower Paleolithic onwards. I'll not get into the details of all this. What we have seen here is lower Paleolithic, middle Paleolithic, and upper Paleolithic have been very well documented and also dated. Dating has been possible. So these are some of the artifacts that we get in the context, geological formations at the base of the hills and so on. And then the valley floor, where we envision the presence of a large lake in the past, also preserves a deposit which is known as volcanic ash, which is of 74,000 years ago age, and has its source in one of the largest volcanic eruptions the earth has witnessed, and that source is in Sumatra. So the ashfall occurred, and it buried some of the archaeological material underneath, as well as above the deposit as well, indicating the continuity of human occupation here. So as a result of the presence of this particular ash, it was possible to establish chronology of these Middle Paleolithic stone artifacts going back to about 74 to 80,000 years ago onwards. So these artifacts come from much deeper than from the base of this volcanic ash, which is about 74,000 years ago. And then this particular sediment has preserved these fresh, mint fresh, very sharp edged flake artifacts here. And for the first time, we were able to figure out the age of the Middle Paleolithic in India going back to 80,000 years. But subsequent work at Atirampakam has given us much earlier age for the beginning of the Middle Paleolithic in the Indian subcontinent. So in addition to these open air stations, we do have cave settlements. One of the oldest cave investigations that was carried out by geologists in India go back to 1884. Although this was discovered in 1844 by one Captain Newbold, Foote was the person who discovered the site of Atirampakam, Pallavaram, and he laid the foundation for prehistory in the Indian subcontinent, rightly regarded as the father of Indian prehistory. Was the first to investigate into these caves, limestone caves, and then he found the evidence of bone tools and some of these blade tools comparable to the Upper Paleolithic in Europe and so on. But subsequent work did not produce sufficient evidence. In addition to these caves, we have these.
Professor Korisettar, if you could,
Yeah.
go to the conclusion, then we can have a panel discussion. That has to also continue. So,
okay.
Yeah.
I thought there's some more about Holocene.
Sure. Take your time, but if you could round it up quickly, then there are lots of questions, and we want very engaging panel discussion to take.
Just be liberal to me. I have something more to talk about during the Holocene.
Sure. Please go ahead.
This is one rock shelter site, another rock shelter again, which we excavated. Here again, for the first time, we were able to figure out the age of microliths, comparable to the Upper Paleolithic or Late Stone Age in Africa, going back to about 40,000 years ago. Now we have very comfortably placed the beginning of microliths in the Indian context, going back to 50,000 years ago and so on. So that is how the Pleistocene archaeology has been steadily progressing and producing excellent results because of the methodologies that are available, because of the dating methods that are now available, and they have been made very, very suitable for establishing chronology of these Paleolithic sites coming from distinctive or variety of geological contexts and so on. And that is one advantage that is given to archaeologists in India to place the Indian prehistory in the forefront of global debates that are now going on with respect to the way in which human colonization of the different parts of the planet has been taking place during the last 2 million years or more. And these are some of those microliths that have been dated to about 34,000 years ago. And then we also get evidence for objects of ornament, beads, and then harpoons and shell beads and stone beads and so on. Perhaps the oldest beads that are known from any part of the Indian subcontinent are found at this site called Jolapuram in the Kurnool Basin of India. And the end of Upper Paleolithic marks the beginning of the Holocene and also end of the Pleistocene and so on. Between 15,000 and 10,000 years ago, major changes in the way in which humans were living in different parts of Southwest Asia and other parts of Eastern Asia and Southern Asia have taken place. What we see is the emergence of sedentism in terms of settled way of life, and they are the first people who transformed themselves from hunter-gatherers to cultivators, and then they were the ones who were also herders. They managed livestock, and then they produced food crops. And then in addition to that, they also invented pottery. So these are some of the distinctive elements associated with the rise of agro-pastoral way of life. See, the early transformations were also accompanied by identification of wild plant food resources in the form of millet, cereals, pulses, oil seeds, fiber crops, and then nuts, tubers, and so on. And some of the crops even coming from far-off places beyond the frontiers of the Indian subcontinent and so on. These are some of the major inventions that take place. Here again, we see West Africa playing a very, very important role in the early transformation of hunter-gatherers into early agriculturists and so on. And near Levant or the Near East or Southwest Asia is one region where we see these transformations taking place from about 15,000 years ago, and gradually developing, as full-fledged agricultural communities characterized by the production of wheat and barley. This is the zone where we have native wheat and barley that were adopted by these early agriculturists in this area. When we come into the Indian savanna region, the beginnings of this transformation is slower when compared to these two regions here. And then by about 6,000 years ago, or slightly earlier, we see the transformation taking place. One such site is Mehrgarh in the Balochistan region. That is the oldest, goes back to about 9,000 years ago, but that gradually gave rise to the rise of urbanization in the Indus Valley, but it did not expand east of the Indus Valley or east of the Aravalis and so on. So on the Indian peninsula, we see similar developments taking place associated with sedentism, associated with agriculture, food production, animal keeping, manipulating land, and invention of pottery, all taking place. And then you go further north, in the northern India, we have these slightly earlier developments taking place. And then you go to North China, it is on par with the developments in Southwest Asia and also in South China. So India lies in between these two broad geographical areas where early transitions or transformations occurred. And that is one interesting situation for archaeologists to understand why this delayed transformation of hunter-gatherer life is and so on. So between Southwest Asia and China or Eastern Asia, we have the subcontinent distinctive agricultural provinces. These are localized traditions, local traditions that we see, which were successful in adopting, in adopting agricultural way of life, and that we see the temporal, frame that we have the point of beginning of these transformations or transitions taking place in different parts of the provinces. We have the Balochistan region, the Himalayan region, Kashmir Valley, the Vindhyas, the Ganga Plain, the Eastern India, and then you have this Gujarat, North Gujarat, then you have Rajasthan, and then Western Madhya Pradesh, then Northern Deccan, Mid Deccan, and so on and so forth. In all these areas, this yellow region marks the adoption of local, food crops, local wild progenitors of cereals, pulses, and millets, and so on and so forth. And there are these distinctive characteristic features associated. So as I mentioned in the beginning, this particular phase of early urbanization that occurred in northwestern part of the Indian subcontinent was restricted geographically, although it occupied a much larger area than the contemporary Mesopotamian or Nile Valley civilizations, but it has its own restricted geography, and its influence was not immediately felt beyond this particular region. Although there have been arguments that Indus influences were there on the inland, early agricultural settlements, it is now increasingly felt that the overland expansion of some of the cultural traits from the Indus and post-Indus time periods did not influence these early agricultural, provinces in the mainland peninsula. So it was the seafarers, as I said in the beginning, coastal seafarers who played a very important role in the introduction of crops from different regions: West African crops, Southwest Asian crops, East Asian crops, and adoption of millets, local millets, and so on. So these are some of those provinces that we see. We have seen 13 of these major conferences, varying in time when it comes to identifying the beginnings of these, traditions, agricultural traditions. So that is one reason where we see the diversity. But gradually, by about 2500 BC, what we see is the entire major part of the Indian subcontinent was fully agricultural and so on. So this integration takes place during the last 4,000 years ago time period. And by the beginning of Iron Age, we see that all those regional traditions have been very well integrated into each one of them. And then there is there's both, dispersal of crops from one region into another region, and then introduction and dispersal also takes place at different points of time into different regional traditions that we see here. The millets we have identified nearly 4 independent centers within the Indian subcontinent. Across the world, we have at least 13 independent centers of agricultural origins. But within India, we see that in the Bengal region, in the Ganga Valley, we see independent evolution of rice agriculture going back to about 5,000 years ago. Here again, millet cultivation, independent of influence from outside the Indian province, occurring around 5,000 years ago. Similarly, here in the southern Deccan region, what we call the southern Neolithic province, we have the early emergence of agricultural way of life, characterized by cultivation of local millets and also pulses and so on. And gradually, from about 2,500 years ago to by about 1,000 years BC, over a period of about 2,000 years time span, we see the expansion of this tradition into much wider geographical area. And then by about 1000 BC, we have northern plains of Tamil Nadu also revealing evidence for the presence of agricultural settlements and so on. So this is in brief. I could cover the geographical and cultural provinces across the Indian subcontinent during the last 2 million years or so. Thank you.
Thank you, Professor Korisettar. That was an outstanding sweep of.
I felt shortage of time.
I understand, but because you had to cover so much.
I reduced number of slides in the afternoon, but yet I was not able to.
No, that's fine, sir. We really enjoyed it, and let me also bring in Professor Rajesh Rao, who gave us the previous talk on Indus. We should have actually sequenced it with your talk first and Rajesh's talk the next one, because where one ends, the other one starts. Of course, you are looking at very different problems, but fascinating. I mean, we have the historic period where we have got written records, epigraphs, copper plates, so much of rich material available. And the previous period, the Indus or the Sindhu Saraswati civilization, call it whatever it is, has so much of archaeological material that we have found, but no writing that we can confidently say this is what it means. And the period prior to that, where we are talking not thousands of years, but hundreds of thousands of years and millions of years, and we are still able to extract something out of that. So my first question to you, Professor Korisettar, how do you find, you say that at this particular period they were growing rice, barley. I'm coming to the much later period, basically. How is it? What are the tools in your hands with which you can actually find out all these things with confidence?
Yes, archaeology is multidisciplinary in nature, and we have an area called archaeobotany. We have specialists. It's a full-fledged discipline, although it is subdiscipline for archaeologists, but there are full-fledged archaeobotanists, archaeozoologists, archaeoanthropologists, archaeochemists, and geochronologists, all of them coming together to help us reconstruct, the lifeways. So what happens is you have phytoliths preserved in the archaeological sediments, or you have some of the grains which were processed, for preparation of food. And some, during the course of processing, some of them were roasted. And if some of them get excessively roasted, they get charred. Once they are charred, they develop a shell, which preserves that particular grain for millions of years, if not hundreds of years. So they are, extracted from the habitation soils, or what we call anthrosols, soils associated with human habitation. And then we have, when we excavate, we have various strata identified, through cultural material, that we get in these layers. And then the soils are subject to flotation, froth flotation. And these very light, organic materials float in water. And they are sieved into, mesh, nylon mesh bags and so on, dried in the sun. And then they are taken to the laboratory for detailed, identification. We have a reference collection, and you also have modern day electronic microscopy and several other advanced techniques, even to get into the cell structure of these grain and so on. And this grain can be directly dated by AMS radiocarbon dates method. So it precisely gives you, and the morphology of the grain will help you to identify whether it is a wild grain or a domesticated one. Cultivation of wild grains over a period of time gives, brings about changes in the morphology of the grain. So that is where archaeobotany helps us identify at what point of time what crops were, identified and cultivated and developed and so on.
Thank you. I'll have to mix up the questions to engage everyone. So the questions may keep jumping from one to the other. Rajesh, lovely to meet you here after our Pune meeting. Thank you, and your talk was astounding, and there was excellent set of questions. So I will keep mixing them up. The first question is from Hari Mani, and he was looking at your entropy of languages slide, and he asked, for calculating the entropy of the languages, what was the corpus used? How did you arrive at those numbers that you presented?
Well, yeah, thank you very much. It's great to be here. And also, thanks to the Tamil Heritage Trust for organizing such a great conference. It's been very interesting, and it's great to meet you also, Dr. Korisettar. It's basically my pleasure to be here. In terms of the question itself, the entropy of languages, this goes back to our paper published in Science, and a more updated version also in the IEEE Computer magazine. And so for the Indus script, we used Iravatham Mahadevan's corpus. In fact, I have the book here. It's this, one of the biggest contributions, I think, to the Indus script is his corpus from 1977, actually, I think the first corpus of Indus script. So we actually had a digitized version of it, and we used that to compute the entropy, which characterizes the amount of randomness or flexibility of the strings as they were composed for those seals that I showed in my talk. And similarly, for the other languages, we used corresponding data sets that are available publicly, for the Sumerian script and also the Tamil script and Devanagari and so on. So in terms of the actual algorithm itself, there's obviously there's only so many inscriptions that we have from the Indus civilization. So we had to use some more sophisticated techniques from statistics and from machine learning to actually make up for the fact that the samples are not quite, the sample size is not huge, right? So there is some amount of, so if you look at the graphs that I showed, there is some amount of a standard error that you can see that we can estimate based on the amount of samples we have for each of those data sets. But the details are there in the science paper and also the IEEE computer paper.
Just to follow on with that, it's a question from Srinivas and Rajagopalan. Initially you showed why the script appears to be from right to left, right? But later on, when you were presenting when splitting the writing, you gave the prefix to terminal. It's from left to right, at least what you presented in the picture. Can you explain why that is the case, or is there something else that we are missing?
Yeah, I think that always comes up with seals and their impression. So if you remember, seals are usually the mirror image of the actual impression. So I need to really, I think this also happened in an earlier talk I had given at TED, which is when I show something, if I mention it's a seal impression, then that is to be read from right to left, which is kind of the way that the Harappans read their script. Typically, it was from right to left. But if I show you an actual seal, it is the mirror image of that impression that right? So I think in the slide that I showed, it was an actual seal, which means that the left to right is what it is the sequence to be interpreted there. But then when you impress it, then it becomes right to left, right? So sorry for that.
So if you could just mark your presentation, that would make it easier to
yes, you should say seal or seal impression.
Yeah, exactly. So here is a couple of questions to you, Professor Korisettar. This is from Professor Thomas Levy, who will be making a presentation to us a couple of days from now on bronze making and related to that. So I invite both of you to attend the talk, and anyway the recordings will be there. So let me ask this question. The first question is, Given the monsoon environment of India and Tamil Nadu, have any Homo erectus remains been found at Rivat and Prabi Hills?
Yeah, we have been on the lookout since 1880s. When first Robert Bruce Put went to the Bilasargam caves in the Kurnool region, and Thomas Huxley had requested grant of the governor of Madras to depute him to go to those limestone caves, because we always geologists always think that calcine environments favor formation of fossils or petrification of biology skeletal material, whether it is human or animal and so on. That was unsuccessful in terms of productivity, finding hominin remains. But even again, we started working in those caves in order to look for even recent human fossils and so on. But as I was emphasizing on understanding the geomorphic environments, across the Indian subcontinent, I was also emphasizing on the groundwater resources and the fact that the rivers which we call seasonal were perennial in the past. And these rivers were perennial not because of surface precipitation that was occurring because of monsoon circulation, but because of post-monsoon spring flow into these channels also facilitated perennial availability of water. And like we have these North Indian rivers which are called perennial river systems and so on. But even these Deccan rivers were also perennial in the past. But as we go backwards in time, the groundwater resources were always stable in spite of long-term and short-term climatic changes. And that is why inland regions, I was repeatedly saying, inland regions were much more well-watered than the region, in the immediate neighborhood of these, the drainage network, drainage systems that we see on the continental landmass. But then what is, because of the lack of desiccating subsoil environment, the high water tables gave rise to formation of perennial what we call wetland areas, a water saturated soil horizon. And if animal or human bones get buried into this such wet conditions, the fossilization is not possible.
Okay.
So these all alkaline conditions, that gave rise to decomposition of the organic material, and that is one reason why lack of desiccating environments. And as you go backwards in time, there was very little demographic pressure on these natural resources of both surface water as well as
Right.
groundwater. So there was a kind of a steady state between surface water resources as well as groundwater resources, and then this particular zone where all our material cultural remains as biological remains become part and parcel of the surface of the earth, they are exposed to these waterlogging conditions and does not facilitate formation or petrification and so on. And that is why we have so far not been able to find evidence for earliest human ancestor, whether it is Homo erectus or early modern humans. Like we have one site in northern India, in central India, on the banks of the Narmada, where we have a site called Hathnora, where in 1982 Dr. Sonakia found a partial cranium preserved in the later Pleistocene deposits. These are all desiccating environments, very dry, semi-arid, calcine environments facilitating formation of but it is not complete. Human skeletal has not been preserved. Fragmentation may have taken place for various reasons, because there's an area called taphonomy, which gets into this particular aspect of initial discard, burial, and then re-exposure until the time they are either discovered by anthropologists or geologists or archaeologists and so on. So these stages contribute to its preservation, either partially or incomplete. But in Africa, they have been very well preserved because most of these human ancestor sites were buried under volcanic ashes, local volcanic.
Right.
So we do not have such a situation except the one I showed in the Jolapuram area. But so far we have not excavated that area extensively. We also hope sometime in future, one of the what we call substrata below the ash will yield the remains of human ancestors in this region. But otherwise, so far, except that particular site, which is Hathnora, it is being debated whether it is archaic Homo sapiens, whether it is advanced Homo erectus, or it is nothing. But it is human, no doubt. So that is the kind of situation here in India.
Okay, and this is a question from Professor Levi again now for Rajesh. Uh, Based on the distribution of the artifacts found with the Indus script, would that argue for a northern Indo-European origin for the script? Now, this is a question that I think there will be a lot of interest amongst the the audience. So your analysis and few others' analysis uh, looks at it as sort of Dravidian in structure, but uh, how do you consider this question in that light?
I think I consider this a very explosive question, right? In the sense that there's been lots of, I think, passion.
Yes.
Especially in India. I think we're so, averse to any kind of, I think the word Aryan invasion theory or AIT is thrown around so much, and it's been completely, there's debunked versus so on and so forth. So I think, we need to get away from that particular kind of, there is a lot of passion there, but at the same time, there's also evidence coming in from so many interdisciplinary sources, right? So in my talk, I just briefly had a slide from the 2019 science paper, looking at ancient DNA,
Right.
and that was published, also with another paper on the ancient DNA analysis from Rakhigarhi, right, which was a single skeleton. This was Professor Shinde, and in fact, the same group of people also had published this earlier paper in September, actually. And I think at least from that particular analysis of many skeletons from South Asia seems to indicate at least that combining that with some of the linguistic kind of evidence that has been around for a long time about the spread of Indo-European languages and so on, it seems to at least indicate that the migration, there are multiple migration waves potentially, right? That seems to be happening after or during the decline of the Indus civilization. And so at least from that evidence and from the linguistic evidence, it seems like it's unlikely that the language, at least there may have been more than one language, right? But at least it seems unlikely that the so-called Indo-European languages were being spoken in this civilization area during that time, during the flourishing of the Harappan time, which should be between 2600 to about 1900 BCE. So I think it's unlikely, but of course we cannot rule everything out. But at least it's intriguing. I think it's an exciting time for us, as people from India. I think the fact that there is now so much interesting research going on in terms of our ancestry, right? And I think we should own that. We should be proud of it. We should be proud that we have these multiple migrations into our subcontinent, from Africa originally, as Dr. Korisettar so nicely pointed out, multiple waves of migrations potentially. And similarly, I think there's no reason to say it stopped after Africa. I mean, there were waves of migrations into India, many times, right? And that's what makes us who we are, I think. So I think that we need to be proud of that, and not be averse to any kind of scientific evidence that comes, and that seems to knock off, one particular hypothesis we hold very dear, right? So yeah, that's my personal opinion.
Okay. I want to bring, in a sense, both the talks together. So we have excellent evidence of a fantastic built-up civilization, which has great cities, thriving economy, and then we have found so many prehistoric sites with I don't want to use the word primitive, Professor Korisettar, because for the given time they were so advanced with whatever tools they could. Yeah, they were advanced. I mean, that in Palavaram, as an example, they could build a factory to create, or at least we think it's a factory. The tools, they're so fascinating. What was that intermediate step? Let's say these various lithic civilizations to an Indus, the burnt brick construction. Have you found anything that sort of nicely, shows possibly the evolution from a stone using technology to an advance that, for example, the Indus civilization had achieved? Is there anything that you can tell us about that, Professor Korisettar?
Yeah, within the larger Indus Saraswati basin area, from westwards, if we start, we have the earliest Neolithic site, which is early stages of agropastoral adaptation to that particular environment. So there is a transition, very quick transition from hunting gathering to early agricultural way of life, which is characterized by domestication of food plants and also these animals. Both of them played a very important role in a very prosperous subsistence economy. These were these primary products, animals and food crops, and also secondary products like dairy products coming from animals and so on. That gradually gave rise to prosperity, and the settlements began to become, well established, and gave supply the nutrition also, contributed to increasing reproductive capability, and then that gave rise to increasing populations. So populations began to split and then gradually expand into newer geographical environments. So any newer geographical environment was a productive geographical environment, not simply a geographical area which is available for humans to go and expand. The productivity is governed by availability of all these essential raw materials, either geological or in terms of the subsistence resources and so on. And that is how gradually, and then when you enter into a new geographical area, you might accidentally encounter a new variety of resource that humans could exploit. And that is how we see gradual identification of metal. Say for example, copper for example occurs in two forms, both as metal and as well as ore. So unless you develop metallurgy, you can't exploit the ore, but you
Correct.
have access to the metal directly, so you start using it. So similarly, as we go backwards into the Pleistocene time period, this was a hunter-gatherer way of life. They were initially scavengers. They were gatherers, and then it was only a domestic kind of an economy. So day-to-day requirements were met with, but the inclusion of animal meat has really contributed to biological evolution. There are so many other parameters which are considered for explaining evolution from Homo erectus to Homo sapiens, and in the intermediate stages of human ancestors and so on. So along with stone, what we see is use of organic material like bone material. If it is preserved in the archaeological record, we know where to place it. But there is a possibility some of these perishable materials were also utilized by along with the stone, and so we can't say. So there is multiple raw materials were already in use by these early hunter-gatherer communities as well. So with ranging habits, the expansion range began to increase in time, upwards in time, and that gave access to newer and newer resource areas. So once you enter a new geographical area, like I was telling you about the geological provinces, so you have the entire subcontinent is not monolithic. You have the basalts in some area, you have charnokites in some area, you have chondolites in some area, you have Karnool, Kadappas in some area. Each one of these geological formations contain multiple varieties of lithic resources, and they also contain these metal resources and so on, ore resources and so on. And provided you have access to these resources, and this is possible only when you enter into those geographical areas, and you can see the transformation taking place. Why in southern India agricultural way of life began much later? At least
Right.
6,000 years time gap between what happened in Mehrgarh in the Bolan Valley and what happened in central India and southern India and so on. These people were self-sufficient and they were well adapted to these environments. So there was no catchment, did not have, did not was not affected by the carrying capacity. The carrying capacity of these catchments were stable, and that is where even today we have hunter gatherers, we have pastoral communities
Right.
well adapted to marginal environments. Okay, so that is what I'm saying. It's a mosaic of cultures. It is not that linear evolution of the entire Indian society from what we call the primitive or first stages of cultural evolution to the most advanced or present stages of cultural evolution. We may call ourselves urbanized or civilized and so on. It is for various other reasons. There are
Right.
these parameters which characterized our status of life ways. That is what I see. There is a gradual evolution, and what we need is we have to be lucky. Archaeology is always depend on luck. See, for example, the site of Athiram Pakkam was discovered in 1880s, and only in 2011 we have a date for the site. 1.5 million years. So archaeologists have been going there again and again,
Right.
and with
Right.
musicians have been working there. So we need to be lucky and to be on the right side, on the right location, and at the right site, which when excavated provides you, documentable evidence to trace the gradual transformations that may have taken place. So, like in the Indus Valley, you have pre-Indus or pre-Harappan, Harappan, and post-Harappan. Very
Right.
gradual transformations you can see, and you can
Right.
attribute, factors, forcing factors responsible for these transformations that were taking place. It was thought it was transported into the Indian subcontinent in the beginning, but once Mehrgarh was found, and then similar sites were found along the foothill valleys of this range of hills. So Sulaiman, Kirtar, and Karakoram. So they
Right.
then became an indigenous, evolution of urbanization in that region and so on.
Right. Right.
So there is adequate evidence already, no doubt
Great.
about it.
Yeah. Thank you. Thank you. That was a fantastic answer. Rajesh, I have a great question for you. You when in your talk you said that we didn't find any Rosetta Stone. Now you have been looking at this research, what others have done, and your own team trying to decipher the script. Now, what would be your wish list? What would you need to actually decipher the script confidently? Uh, like Princep did with Brahmi, like of course the cuneiform and the Egyptian, etc. What is a minimal or the linear B? What is a minimal requirement that you would need to crack the script? That's question one. And the continuity of that is what Dr. Kupuswamy has asked. Are we confident that we have got the complete character set of Indus script? Is there a possibility that we are still missing some characters? Right. So if you could just combine the two and then give me an answer, that would be great.
I mean, I guess the wish list, if you're really saying it's a wish list and you can wish anything, would be, if you could directly talk to the Harappans, right? I mean, that would solve all our problems, right? But unfortunately, we cannot do that unless we invent a time traveling machine, right? So what we really need, I guess, I mean, ideally, maybe there is something like, quote unquote Rosetta Stone, because we do know that the Indus people traded with, other cultures, including the Mesopotamians, right? And we know how to read cuneiform. So that would be probably the most possible. If there is, a Rosetta Stone of some sort, maybe there was some sort of a trade agreement or some type of an artifact that has Indus inscription alongside, some cuneiform inscription, right? And who knows, maybe it's already been discovered, it's lying in some museum in Baghdad or somewhere in Iraq, right? We just haven't been able to go there yet, right? So people haven't realized it's got these two inscriptions. But barring that kind of an artifact, right? I think the other wish list, other thing that would really help us would be longer inscriptions, right? So even when, Dr. Bish found the Dolavira, a signboard, it was actually ultimately not a very long inscription. Just
it was just large. But
yeah, it was just large in size, but not large in the number of symbols, right? So unfortunately, we also were not able to get a very large, inscription there in terms of the number of symbols. So I think ultimately, we are hoping still that there are still lots of archaeological sites that have not been, excavated. And we're hoping, for example, in some of the bigger sites like Ganveriwala, which is actually in the Bawalpur district in Pakistan. There's also Rakhigarhi, right, in India. So hopefully, one of these unexcavated sites, there's so many of them that maybe one of them will have something that has more than the average of 5-6 symbols on these seals, right? So we're hoping for that. Even if you have something that like I said in my talk, there are these patterned inscriptions which seem to be more sort of economics kind of in nature, in economical nature, about trade and so on, transactions. But there's also these more quote unquote complex texts that seem to have more of a linguistic character to them. So if you can get these longer, sort of more of these complex texts, that will help us a lot in understanding the underlying linguistic basis and syntax and so on for the underlying language. And in terms of the question itself about characters, I think we don't know if we have a complete character list, right? In fact, it's even trickier with the current set of inscriptions because some decipherers will say there are 200 characters, 200 symbols. Others will say there's 400. In Irvada Mahadevan's book, there's 417 that he comes up with. whereas Brian Wells and Andreas Fools, they currently have 700 symbols. Right? And the reason for that variance, from 200 all the way to 700 is because of how you classify the different variations in the same symbol. So the same symbol might be written slightly differently across by different scribes or different regions. And so it depends on how much you want to collapse them all into the same symbol versus keep them separate. And there's multiple ways in which you can do that. So right now we have about anywhere between 200 or 400 or 700 symbols, and depending on that, you may have slightly different results or dramatically different results, right? So we even don't have a very good count of the actual number of symbols. We have some notion of what the symbols are, and sort of average number around 400 or 500, but yeah, the exact number is still uncertain, and it may change as we get more artifacts excavated.
Yeah, in your talk, that the sort of numbering system in a binary format, that was really fascinating. Like 1, 2, 4, and using them to possibly create. I mean, these are all, we're still talking about speculations, but the excavated material gives us the weight range. Now that is really fascinating. I mean, connecting that. In fact, we are going to have a session on mathematics in ancient India tomorrow. So hopefully that will give us, of course, we are talking about a considerably later period, related to this time period. It's really, I mean, for us, this whole Indology festival starting yesterday has been really exciting because we get to hear voices from around the world focusing on various Indic studies. Little bits and pieces only, really, if you really look at it. I mean, the whole of prehistoric civilization, cultures that have been spread across. How can we present it in 1 hour? And Professor Ravi Korisettar had done an outstanding job. You took, Rajesh, you took just one aspect of it, and particularly the fish symbol, that particular explanation, but overall still, in the overall Indus, material that we have found, the most vexing problem of unraveling the script and where we are. I mean, it was a very nice overview. We are running out of time. I have lots of questions, but I don't want to. It's very late here for Professor Korisettar and for
it's okay.
Rajesh Rao. It is fairly early in the day. No, we are trying to bring somebody from the west coast of US and India. So it was fascinating. I mean, I can keep asking questions. There are a list of questions, but in the interest of time, we will close it today. But thank you very much for an extremely entertaining talk. Very easy for a lot of people like us with no background whatsoever in these topics. I'm talking here on behalf of all the audience, and there are, of course, people who are well versed in this topic also present there during this talk. We thank you for your lecture and your presence, and taking all the questions on and answering. Thank you very much, and that was a great session. Thank you.
Yeah, thank you.
And
thank you.
thank you.
Thank you. Thank you so much.
Yeah, you want to add anything? Yeah. Yes, sir. Yeah. Thank you. And please go ahead, Professor Korisettar.
Someone wants to ask questions, they can email us also.
Yeah, we will collect. We have collected a lot of questions. We will send them over to you, and we can then collect the answers and then share them.
We want more people to be interested in archaeology.
Absolutely. So
very small population now.
Yeah. There's one thing that yesterday Professor V.S. Ramachandran, the neurologist, when discussing yesterday, he said this is archaeology is still one area where amateur enthusiasts can also do at least something. I mean, you can't necessarily do it in other areas, right?
Yeah,
at least their sheer interest they can bring and perhaps contribute.
They contribute more.
Yeah, and we really hope those of us who are listening to this program get seriously interested in archaeology and contribute their might. Thank you all once again from Tamil Heritage Trust, and we look forward to your presence tomorrow. Once again, thank you.
Yeah, thank you so much.
Pleased to see you, Dr. Rajesh.
Thank you. Yeah, great to meet you too.
With this program.
Thank you very much.